Hello everyone, I'm Caroline Brandt, and today I want to tell you about our research where we try to help developers fix their failing test cases faster. We did this together with our master student Caspar Boone and Andy Seidman. We are in the area of continuous integration, which is an integral part of every software engineering project nowadays. Whenever a developer made a change, they push it to the CI server, which compiles and builds the code and then executes the test cases. One of the major reasons for these CI builds to fail is because test cases fail. So the change that we made broke something else that we didn't expect to break. Now, when this happens, the developer has to go out of their work and out of their development environment, look at the CI web page, try to figure out which test failed, then go back to their IDE and try to see, okay, what was the root cause that made this fail now? Which changes do I have to do? Whereas if they execute the test cases in their local IDE, there's a much nicer interface for them. They have a list of which test cases failed. There's directly information on the error log, even with links that directly send them to the related classes. So there's quite a usability disparity between running on continuous integration and in your local IDE. However, developers might not have the power to always execute all the test cases locally. So that's what inspired us to try to bring this information from continuous integration into the local IDE. For this, Caspar developed a IntelliJ plugin called Test Access, where whenever a build is completed, the developer gets a small notification, hey, your build completed, your build failed, and then we show the developer all kinds of information that we gather from the CI server. We show metadata about which test case failed, and we also show the error message, including the nice links that send you directly to the involved classes. Then we also show the code of the test itself, because maybe that's what needs to be changed. That's what brings the developer to find the error. And a special feature is that we show the changed code under test, because we have the assumption that this is an intrinsic error. That in the last build, the test case passed, and now the test case fails, so the changes that were made to the code in between are somehow responsible for this failure. In addition, a test case, we say, is only influenced by code lines that it executes. So these code lines influence what's the outcome of the test case. So combining these two kinds of information, what is the code that changed and what is the code that is executed by the test case itself, brings us to the lines that the developer should likely be focusing at, because that's where we expect the error to be. And this is what we show in this kind of coverage view. We have green, the changed lines, in yellow, the lines which are covered by the test case, and then in purple, those where both is the case. So these are likely the lines that the developer should focus on that somehow lead to the error. The question that we asked ourselves is, does this really help developers fix the test cases faster? So we conducted a user experiment with 16 participants, and their task was to fix a failing test. And we compared the plain GitHub pull request interface against the Test Access plugin interface. We had 4 categories of test cases that the developers had to fix. And they are separated by which information is needed to spot the root cause of the error. The metadata, the code of the test case itself, or the code under test. And for the last group, we have a simple and a more complex case. Let me show you the results that we saw during our experiment. This is a box plot on how long it took the developers to fix the failing test cases. We saw that if you could spot the error in the metadata, on average, the developers were faster with the plugin than with just the plain GitHub interface. When the error was to be spotted in the test code itself, a lot of the developers hit our time limit on the 5 minutes that we had, but still, on average, they were faster with the plugin than without the plugin. For the changed code under test, where the error was somewhere to be spotted in the code that was changed and was executed by the failing test case, In the simple cases, the developers were much faster with with the plugin than without, and this is actually a statistically significant result. However, in the complex cases where the kind of error which was much harder and much more hidden, our results are inconclusive, because in the first case, the developers took longer when they used the plugin, and in the second case, they were faster when using the plugin. We try to analyze the data a little bit further to explain why they took longer in one of the cases. And one thing that we found is that more experienced developers took more time when using the plugin than less experienced developers. And one possible explanation that we are having is that it's for experienced developers more difficult to add a new tool to their tool belt, whereas new developers might accept the features of the new tool more easily and not have already their predetermined way of solving such a failing test case. Overall, we observed that when the developers had the plugin, they rarely needed to rerun the tests locally in the IDE, and that was what saved them so much time here. The participants themselves said that the tool is really useful. They liked that there is less context switching between IDE and browser, and their most favorite feature was the changed code under test that let them really focus on the lines that are likely important to fix the test case. If you want to know more or you want to try out the plugin yourself, go to github.com/testaccess, and if you want to have more information about our paper, everything is down below in the description. Thank you.